Alrighty there, folks. We are talking today about similar figures, and this is none of those topics that comes up quite a bit in real life, such as blueprints for houses or buildings or stuff, maps or GPSs for finding your way, models used by architects and auto designers all over the world, and a bunch of other places that I can't think of. Anyways, so scale factors, similar figures and scale factors are all kind of part of the same discussion. So what the heck does it mean for two figures to be similar? This actually goes back way back to grade 9. Here is the definition we gave you way back then. Basically, they're just two figures or things that have the same shape but are of different size. And the way you tell that with these two different criteria. Like, for example, identical corresponding angles. So it doesn't matter what the angles are, so long as the corresponding angles are the same. So for example, these two triangles are similar because they both have a 90-degree angle there, and the big angle is equal to the dot, and the small angle obviously is equal to the little circle there. Okay, so the corresponding angles are the same. It also applies to quadrilaterals or polygons of more than 4 sides, so long as the corresponding angles are equal. The second thing is that the ratio of corresponding sides are equal, or is equal for all different set of corresponding sides. So for example, these two trapezoids, to see if they're similar, we would look at the ratio of corresponding sides. So starting with, and you can do it kind of in any order, just as long as you do it the same way all the time. So if we do the small one here over the bigger one, that's the corresponding side there, the short side. So 6 over 9. Is that the same as, say, 4 over 6? And is that the same as 10 over 15? Okay, and as a matter of fact, they are all the same. They're all equal to 2 over 3. Okay, so because those are all equal, those are similar figures. The good news is you don't have to look for both. Once you know one of these is true, either 1 or 2 is correct, it automatically implies the other. So if you know the corresponding angles are equal, that means that the ratio of corresponding sides is also equal, and vice versa. So, for example, these two triangles, to figure out if they're similar, you either have to look at their corresponding angles or the ratio of corresponding sides. But obviously, you don't have the angles, so you have to work with the ratio of corresponding sides. So, set up 3 different ratios of corresponding sides, work out what the value is for all 3 of those, and check to see if they're the same. If they are, they're similar. Go! Okay, so you get this all worked out here, and you get really, really close, but the problem is this last one is 1.49. So that last ratio is not exactly 1.5 like the other 3, or 2 are rather, so they are not similar figures. But if they were, if this, for example, said 8.85, and this said 8.85, then you would for sure get 1.5, and it would be. So there you go. Okay, so that's how you figure out if two figures are similar, or you can also look at their angles as well. The other annoying little tidbit of information we have to discuss here is called the scale factor, and the annoying part is just that they are very picky about how you express a scale factor. And so this is the way they want you to do it. It's always the image dimension over the object dimension. That may be kind of hard for you to remember. So there is a little acronym you can use to remember that. It's SFIDUD, right? So scale factor is the image dimension over the object dimension. See? So easy to remember. Just remember SFIDUD, and you'll get I'm just kidding. Okay, so next video, and I'll have a couple of examples for you.